Hi everyone, just doing another video on collisions again because my lot have got mechanics soon, and so yeah, quite rightly they're looking at these kind of questions because these are some of the toughest. Okay, so quite like this question. It wasn't too bad. It was very similar to another question I helped somebody else with. I can't remember, with Phoebe or something. So Emma, yeah, you're not alone in finding these ones tricky. They are tricky. Okay, what do we know? We know that this is 6 minus 8. We first have to find a range of possible values of E. I suppose like on this one, the rebound, well, 6 stays the same. And the rebound, it's going to be 8 times whatever E is, because E is the coefficient of friction between this one and this. And we know that that's parallel to 2, 1. Well, to find the range of possible values of E, you've got to realize that this vector here, which is 6, 8E, whatever E is, because E you just multiply by the direction perp to the plane, ignoring the sign because you're going to make the sign positive, sorry, because it's bouncing up. But it's just like the ratio between that bit and that bit, isn't it? So if I times this by E, I should have the velocity component for J after the first impact. Now, if you think about it, there's not going to be another impact with S and T if this one is steeper than the wall, yeah? Provided it's less than steep than the wall, then you're good. Now, if we scale this 2, 1 up, because that's just the direction of ST, if we scale it up to 6, 3, we can compare 6, 8E to 6, 3, yeah? Now, as this one becomes steeper than 3, this arrow points up like that, and we don't get another impact with ST. But provided AE is less than 3, we will have another impact with ST. And so we can just say by inspection, 80 needs to be less than 3, yeah? If it's equal to 3, it goes parallel to it, so it still doesn't strike it. So it has to be strictly less than 3, and therefore E is less than 3/8, yeah? Now, E has to be bigger than 0, because otherwise it would be a perfectly inelastic collision. It would just go donk and stay there. And hence we've got our final answer, 0 is less than E, which is less than 3/8. Yeah, so E is trapped between 0 and 3/8. Now, the value of E they give in the next part seems to confirm that. At least it certainly agrees with that condition, so that's good. So for part B, it's one of these ones where we want to basically do a rotation. That's the way I prefer to do it. So we know this one's still parallel to 2, 1, and we know that this is, now we know E is a quarter, so we're going to find a quarter of 8, which is 2. So this is going to bounce up 6 minus 8 and then 6, 2, yeah? And then let's call this one like, if you like, vector V, and we're looking to find V. Well, what we can do is we can rotate the whole problem, if this is theta degrees clockwise, yeah? So that everything's flat. So I want to rotate this vector theta degrees clockwise. Find out what I'm dealing with, then apply my coefficient of restitution and half the y component, if you like, and then I can rotate it back theta degrees anti-clockwise to find V. That's what I'm going to do. Now, rotating theta degrees is not a problem because you've got this general formula for anti-clockwise rotation about the origin. We want a clockwise rotation, and at that point, that minus just goes from there down to there. So that's what I'm looking at doing. So I'm going to write out firstly theta 2, 1. That will be root 5. Therefore, cos theta is 2 over root 5, and sine theta is 1 over root 5. And now I can do a rotation with a matrices. I need to do cos theta minus sine theta down here, sine theta cos theta. So I'm going to have 2 over root 5 minus 1 over root 5, 1 over root 5, and 2 over root 5. And I'm going to be multiplying that by the vector 6, 2. So I'm just trying to rotate this so that rather than it being wonky, it will be going down like that, yeah? Because then I can just easily, because my vectors will be parallel to and perpendicular to the, parallel to the point of contact or perpendicular to it, I can easily apply the coefficient of restitution after I've done this. So that times that plus that times that, I'm getting 14 over root 5. That times that plus that times that, I'm getting minus 2 over root 5. Yeah. Apply E, and we can see that afterwards, as we know that this is now going 14 over root 5 and minus 2 over root 5, and E is a half for the second point of contact, this rebound vector is going to be 14 over root 5 and 1 over root 5. Just make sure you change the sign. So all we've now got to do is rotate back no rotate, theta degrees, anti-clockwise. Yeah, so I'm going to take this new vector and rotate it to turn it into v. Yeah, I can say that v equals, okay, we're going to have 2 root 5, 1 over root 5, minus 1 over root 5, 2 over root 5, and I'm going to be multiplying that by 14 over root 5 and minus 2 over root 5. Oh, sorry, and 1 over root 5. I apologize, I'm looking at the wrong thing. Easy to make a mistake here, but bungle it. Okay, right, that times that plus that times that is 28 over 5 minus 1 over 5, which is 27 over 5. And then that times that plus that times that is going to be 14 over 5 plus 2 over 5, which is 16 over 5. And so I hope the final answer, and let me know if it isn't, is going to be 5.4i and then 3.2j. Yeah, and there we go. That is in terms of I and j, the velocity of B immediately after impact. I could have used complex numbers, didn't feel like it today. I've got the impression that maybe I've been bugging you all a bit with a complex numbers trick. Nobody else uses it. The textbook always uses the routine with the dot product, which is another very elegant way of solving the problem. And yeah, please do look at that approach if you don't like it. I'll happily include it in a video as well. Maybe in the next collisions question I'll do that. But it's 3:29. I've got to be in a meeting in a minute. So hopefully you found that useful. I do like the matrix approach. I think in the exam I'd probably use that approach myself. It's just, you get the formula for rotating and I can see exactly what's happening and what I'm doing. So yeah, hope that was useful. Keep up the good work and bye-bye.